Radix sort is a linear sorting algorithm that sorts elements by processing them digit by digit. It is an efficient sorting algorithm for integers or strings with fixed size keys. The key idea behind radix sort is to exploit the concept of place value. It assumes that sorting numbers digit by digit will eventually result in a fully sorted list. Radix sort can be performed using different variations, such as least significant digit radix sort or most significant digit radix sort. Radix sort can be a very efficient algorithm when dealing with a large collection of items with small keys. It's particularly useful in situations where the keys have a relatively small range of possible values. However, it's not as effective when dealing with keys that have a large range of possible values or are significantly varied in length.
Hey and good day. Today I will be explaining the Radix sort algorithm, a powerful tool in the realm of data structures algorithm. Now, first, let's understand why sorting is so important. In computer science and everyday life, we frequently encounter data that needs to be arranged in a specific order, whether it's a list of names, numbers, or any other information. Efficient sorting is the key to optimizing search and retrieval operations. Now, Radix sort is a unique non comparative sorting algorithm that excels at sorting integers, strings, or any data with discrete keys. Unlike traditional comparison based sorts, such as quicksort or merge sort, Radix sort doesn't compare elements directly. Instead, it leverages the place value of digits or characters within the data to sort them. So, how does Radix sort work? Let's break it down into 5 steps. First, find the maximum value. Start by identifying the maximum value in the dataset. This determines the number of iterations needed. Second is least significant digit sorting. Begin with the rightmost or least significant digit. Sort the data based on this digit using a stable sorting algorithm like counting sort. Then repeat digit sorting. Continue sorting by each digit position, moving from right to left. Each iteration ensures that the data is grouped and ordered correctly. Fourth step is concatenate the buckets. After sorting by each digit, concatenate the buckets to obtain a partially sorted array. Last step is repeat until it is sorted. Repeat the process for all digit positions from least significant to most significant. When you finish the last iteration, you have a fully sorted array. This will be further explained or showed later on. Now, the efficiency and complexity of the radix sort. The radix sort's complexity is big O of k times n, where n is the number of elements and k is the number of digits or characters in the maximum value. It is particularly efficient for large datasets or when dealing with fixed size keys. Unlike some other sorting algorithms, radix sort has a linear time complexity, making it a valuable choice in specific scenarios. In conclusion, Radix sort offers a unique approach to sorting data by examining individual digits or characters. Its non-comparative nature and linear time complexity make it a powerful tool for specific applications in data structures and computer science. Whether you're sorting phone numbers, sorting records in a database, or any other scenario where the keys are discrete, Radix sort is an algorithm worth using or learning as your tool. That's all for the explanation. It will be further explained and showed in the next reporter.
To sort an array using radix sort in ascending order, these are the steps. So we have here our unsorted array, for example. So first we will look for the largest element in the array. We can observe among these numbers, the largest elements have 3 digits. So this would mean that we need 3 passes to sort this array. Now on to sorting. We will first sort them based on the rightmost digit. So the rightmost digit in each number are 0, 2, 8, 9, 1, 3, 5, and 4. With that, we will sort them from least to greatest. Starting from 0, so let's copy 130, and then next 1, so 11, next is 2, so 22, then 3, 23, then 4, 14, 5, 25, 8, 198, and last 9. So this would be our first pass. Then next, we will do the same process but with a digit in the tens place. If ever the number doesn't have a digit in its unit place, we can substitute it with 0. So following the array from the first pass, the next digits we will sort are 3, 1, 2, 2, 1, 2, 9, and 0. Since the number 9 doesn't have a digit in the tens place, remember that in the case of 2 or more numbers having the same digit in the unit place, such as the 1s and the 2s, sort the first number that appears in the array from the left. So let's start sorting it, starting with 0, 9, and then the first one is 11, since it is the first one that appears from the left. Then 14, then 22, the first two, then 23, then 25, then 130, and then 198. So we can observe that the array is already sorted, yet we will just continue the process with the digits in the hundreds place since we need to finish it in 3 passes. So automatically, these 1 and 2 digit numbers will start with zeros. Then we have 1 and 1. And now we have our final pass and our sorted array. 9, 11, 14, 22, 23, 25, 130, and 198. That will be all for the step-by-step process of Radix sort.
Hello, and for this part, we will be discussing about the Radix sort's complexity analysis, where we will be discussing about its space and time complexity. So first up would be its space complexity. In a Radix sort algorithm, we have a space complexity of big O of n plus b, where n is the number of elements and b is the base of the number system. This space complexity comes from the need to create buckets for each digit value and to copy the elements back to the original array after each digit has been sorted. Next, we will be discussing about its time complexity. Here we will be discussing about two notations. First would be big O of n of k times n, where k is the number of digits in the maximum value and n is the number of elements to be sorted. And the other would be big O of D times open parenthesis n plus b close parenthesis, where D is the number of digits in a given list, n is the number of elements in the list, and b is the base of the number system being used. The time complexity for a radix sort algorithm can either be big O of k times n or big O of d times the sum of n plus b. Regardless of which you use, the underlying principle remains the same. The time complexity is proportional to the product of the number of elements and the number of digits in the maximum value. So here we have its worst case time complexity, where it will occur when there is a significant variation in the number of digits among the elements in the input array. In this case, the algorithm may need to perform multiple passes to sort the elements, which would be equal to the number of digits in the maximum value. The average case time complexity for a radix sort would occur when the distribution of values is relatively even across different digits. However, it may degrade if there are extreme variations in the number of digits. And its best case time complexity would occur when all elements have the same number of digits. Regardless of the distribution of input data, the radix sort would always need to perform a fixed number of passes to ensure that all elements are sorted. So here I have compiled the advantage and disadvantages of a radix sort as compared to other algorithms. Its advantages would be is that it contains a linear time complexity for certain cases. In best case scenario and average case scenario, radix sort can achieve linear time complexity, and this can make radix sort highly efficient for sorting a large number of integers with bounded digit lengths. Next is that it contains stable sorting. Radix sort is a stable sorting algorithm, which means that it preserves the relative order of equal elements. And lastly is that it contains no comparison operations. Unlike comparison-based sorting algorithms like quicksort and merge sort, Radix does not perform comparison operations on elements. This can make it more efficient for certain types of data. However, Radix sort is not without its shortcomings. First is that regarding its space complexity. Radix sort can have a higher space complexity compared to in-place sorting algorithms because it often requires additional storage space for the buckets used during sorting. Next is that it is not suitable for all data types. Radix sort is specifically designed for sorting integers and fixed size keys with a known range of values. And lastly is that it is lower for large key lengths. If the key lengths or the number of digits or characters are very large, Radix sort may require many passes, leading to increased time complexity, and in such cases, comparison-based algorithms may prove to be more efficient. In summary, Radix sort can be highly efficient for certain types of data, particularly when sorting a large number of integers with bounded digit lengths. However, its efficiency compared to other algorithms will still depend on specific characteristics of the data and the requirements of the task. Thank you.
Here's the sample code for the radix sort algorithm in Java. First, we need to define the necessary Java library, of course, and define the radix sort class. Here in the first part, the counting sort part, we are using counting sort to sort elements based on their significant places. Next, we are finding the maximum elements in the array, which is this part. Next, we are creating a count array to store the count of each element, which is this. Next, this is the part where we calculate the count of elements, the cumulative count, and then placing the elements in a sorted order. And lastly, for this part here, we are copying the sorted elements from the output array to the original array.
The code defines a radix sort class, which contains the radix sort algorithm and related functions. The counting sort function sorts elements based on a specific place value, using a modified counting sort algorithm. The getMax function finds the maximum element in the array, determining the range of digits, while the radix sort function is the main sorting function. It iterates through each digit's place value from least significant to most significant and calls counting sort for each place. Inside the counting sort function, it creates an output array, calculates digit counts, and sorts elements based on the current place value. Lastly, the main function demonstrates the code's usage by sorting an example of array and printing the sorted result. Thus, this code employs the radix sort algorithm to sort an array of integers by considering individual digits, achieving ascending order.